In this example, we have three function definitions. Function definition is made up of function name, a list of parameters, which can be empty, like in this example of a main function, its return type, and the body of the function, which is basically a collection of statements that make up the implementation of this function. Of course, implementation of the function, its actual code, can make calls to other functions. So these are examples of function definitions. When C++ compiler finds a function definition, it generates the entire function, including its implementation. So formally, function definition consists of function name, the list of argument declarations, which can be empty, its return type, like an integer or double, and the body of the function, which is designated by these two brackets, and a combination of variable declarations and programming statements. So this is a minimal function definition with just the name, the void return type, which means that the function does not return any values to its caller, and empty body of the function. Sometimes functions like this can be pretty useful when you're thinking about a specific function but don't have yet time to implement it. So you can just write it down like integer get user input, and for now you can simply hard code it to return 0, for example. And so this is pretty close to an empty function, just a definition of the function which has yet to be implemented. So sometimes you can place a comment here that would explain that this is not yet implemented. Despite the fact that the idea of function definition, like this, is pretty simple, there could be a problem with it. For example, if I take this function definition and just cut and paste it down here, let me just get rid of this, which I added temporarily. So this is the same program. The only difference is that I moved this function definition after function main. If I try to build this function, I'm getting an error that tells me that identifier square is not found. A rationale behind this approach is that in C and C++, when we are using identifiers or variable and function names, every name has to be defined or declared before it can be used. This is because C++ compiler is a one-pass mechanism. Its approach is just to parse our source code top-down, and everything that we do here has to be somehow declared and explained to the compiler. So when we move the definition of this function down into this place, a compiler complains that this identifier is no longer available and it doesn't exist. So what we can do to solve this problem is to declare a function before it is defined. If we prefer to keep this function definition down in this place, or even if we want to move it to a separate file, we can still use this approach if we provide function prototype or function declaration. Function declaration simply is a signature of function without the body in only a semicolon. So this is a declaration like declarations of variables are using a semicolon. Likewise, function declaration is also having similar structure, but compiler knows that this is a declaration of a function because it has a name followed by the parentheses. So in its syntax, compiler understands that this is a declaration of a function, and then of course return type is also part of that syntax. So declaration is when the body is not provided but only a semicolon. At this stage we also have an example of using this identifier, and this is a function call. So we're compiling main function now, and we're trying to compiler will try to figure out how to generate code that makes a function call. To be able to generate code to invoke the function, it's sufficient for the compiler just to know the name of the function, the list of the parameters, and the return type. The actual implementation of the function isn't important for making the call or generating a set of CPU instructions to create this function call. So this works, and this function declaration should eliminate this problem from my build. And finally, this is a function definition. So this is a very simple approach to be able to make placement of function definitions independent of overall structure of our program that includes function calls. C++ allows to specify function declarations before their use, and eventually someplace we must provide a function definition. So if I build this new version of the program, you can see that the original problem is gone, and now it compiles just fine. In our slide we have this example where if we try to build a ping pong game, and we have an idea of two functions, ping pong, that actually invoke each other. If we take a look at the example of such program, I'll just copy this code from the slide and try to walk you through this example. And of course I will also get rid of these includes. So here we have a global variable named shot count, and this is for ping pong simulation, which the number of shots would correspond to a number of messages ping and pong printed on computer screen. So if you notice, the logic of this application is that we say let's play, and of course this is where the execution of this program begins. And although it seems like everything has already been defined on top of function main, in reality when we make a first call into ping, which is right here, it intends to do some processing, print a message, and then calls a function named pong to print the next message. However, you see that the definition of this function happens to be after the intended use. So again, the solution to this is to be able to declare these two functions before we can start using them the way we like. So it's ping and pong, and you just have to add semicolons to make compiler understand these two lines as function declarations. So this way, if we build the program, this original problem will be resolved. So, and on the next slide we have these two prototypes also added here. So function declaration, actually it's declarations, it's synonymous to function prototypes. So you can use these two interchangeably, function prototypes or function declarations. It's the same thing.